All right, we looked at how to classify our polynomials, so now we want to look at how to get a general sketch of a polynomial. And the general shape of our polynomial is determined by a couple of things. First of all, I can look at the degree of the polynomial. That degree affects a couple of things. It affects the shape of the graph, and it determines the maximum number of turning points. We'll talk about what those mean here in just a minute. The maximum number of turning points. Now notice I said the word maximum here. It doesn't necessarily tell you how many of them there are, but it tells you what the maximum possible number of turning points are. That maximum is always 1 less than the degree. So if I have a degree 4, the maximum number of turning points is 3. If I have a degree 5, the maximum number of turning points is 4. And then the degree along with the sign of the leading coefficient. Remember, the leading coefficient is that number that is in front of the variable that has the highest exponent. So the sign of that leading coefficient, is it positive or is it negative, determines for us the end behavior of the function. What is it going to do as your x value approaches infinity or negative infinity? As you get to the ends of your graph, not necessarily what happens in the middle, but what happens as you get out toward the ends on your graph. And let's do a quick summary of this, and then we'll do some examples, and I think it'll make a lot more sense. If we look at a leading term in a polynomial, so our polynomial can have absolutely anything in it as we continue on out. If our leading term is ax to the n power, first of all, that a could be a positive number. I could have 4x squared. I could have 8x cubed. I could have 9x to the 10th. But that a value is positive. Then if my exponent is even, if it's 2, if it's 4, if it's 6, then my function is going to go up on both ends. Somehow or another, no matter how many little twisties and curves are in between, it's going to go up on the ends. If the power is odd, my degree of my function is odd, and this a is positive, it's going to go up to the right. It's going to go up and up and up and head toward infinity. But on the left, it's going to go down toward negative infinity. If the a is negative, well, think about what we know about reflecting things across the x-axis. If I have negative 4x squared, what happens on the ends? Both ends approach negative infinity. They go down. So if n is even, a is negative, it goes down on both ends. If n is odd and a is negative, well, that's not exactly what it's going to do. As it goes from left to right, it's going to go up as you go to the left-hand side, and it's going to go down as you go to the right-hand side. So let's look at some examples of that just to make that make a little bit more sense, and I think you'll find that this concept is actually fairly simple once you see what it looks like. So an example, what if my function is y equals x to the 4th minus 3x cubed plus 5x. And we'll look as we go along at some more examples of exactly what that looks like. But let's get an idea of our general shape here. Well, look at this leading term. My highest power is x to the 4th. So it's a 4th degree polynomial with a leading coefficient, even though we don't normally write it, of 1. So my degree is even, and my leading coefficient is positive. My 4 is an even number. My 1 is a positive number. So what does this look like on the ends? Well, on the ends, it's going to go up. We have even and positive, it goes up on both ends. Now, we might have twisties here in the middle, but it's going up on both ends of the function. Well, let's do another one. What if I have y equals x cubed? A little different situation. I have an odd degree polynomial. And my leading coefficient is positive. So this function, if I draw a quick sketch, is going to go down as I go to the left, but it's going to go up as I go to the right. As x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches infinity. That's another way to say that. I can say as x approaches negative infinity, y approaches negative infinity. And as x approaches infinity, y approaches infinity. So I can write that as saying, I'm just saying, it's going down as you go to the left. It's going up as you go to the right. All right, so what happens when we get some negative ones in here? We haven't done any of those yet. What if I have y equals negative x squared plus 6x? Well, what's the difference here? Well, we are even in our power, and we have a negative leading coefficient. So even and negative, well, it's going to go down on both ends. It's going to go down as we go to the left, and it's going to go down as we go to the right. How many turning points? How many places can it change direction? One less than this. It changes direction once. Up here, how many times does it change direction? 1, 2, 3. 3 turning points. Maximum number of turning points. Right? One more example here. What if my function is y equals negative 3x cubed plus 4x plus 2. What do I have? I have odd and I have negative. The 3 is odd as my exponent, and my negative 3, my leading coefficient, is negative. Well, what does this function look like? It goes up to the left, it goes down to the right. So we have a general idea of the shape of our polynomial based on two things. Based upon whether this degree, whether this highest power is even or odd, this one was even, and whether this leading coefficient is positive or negative. Shape of our polynomial.